finish or continue in the linear equations with two variables section, and we're going to begin by focusing on slope. And with slope, it gets confusing at times because there are 4 different ways to obtain slope. The first way is to find the slope when you're given a graph. The second way is to find it given 2 points, which is going to be a formula. The third way is to find it given an equation. And then the last one is to consider the special cases of the vertical and horizontal lines. In part 1, if we find a slope given a graph, it needs to be a very nice graph, a very friendly graph, and we find the slope by counting the rise over the 1. So in example A, we'll start at the lower point and determine how high we have to go to be as high as the second point I have identified on the line. So here we're going to rise by going up 1, and then we're going to run by going 1, 2, 3, 4, 5 units to the right. So right 5. When we move up, that's a positive value, and we move right, that's a positive value. So the slope of this line is 1/5. Our example B, again to find the slope, we will start at the lower point, and we will rise 1, 2, 3, 4, 5 units. So again, we go up 5, and now we're going left 1, 2. So we go left 2. Up is positive in the vertical direction, but left in the horizontal is negative. So this line has a slope of a -5/2. Now remember, slope is a number. It's not an equation. It's not a variable anywhere around it. It is a number. Okay, part 2, second method of finding slope, is finding it if you're given 2 points. So somewhere out there there's a line, a straight line going through those 2 points. We want to know the slant or the slope of the line. So this comes into the formula written in red, y2 minus y1 over x2 minus x1. So we let the first point be x1, y1, and the second point be x2, y2, meaning x1 is -2, y1 is 1, x2 is 3, and y2 is 2. So when I come in here and calculate the slope, y2 is 2 minus y1, which is 1, over x2, which is 3, minus x1, which is a -2. So 2 minus 1 is 1 on the top, 3 minus a -2 is a +5, and the slope of the line that passes through those points, the straight line passing through those points, is 1/5. Part B example, we're going to claim this x1, y1. x1 is -1, y1 is 2. And on the next one, x2 is equal to 1 and y2 is equal to 3. Now we return to using the formula in red, and we get slope equal to y2, which is -3, minus y1, which is 2, over x2, which is 1, minus x1, which is -1. So this is a -3 minus 2, which is a -5, and 1 plus 1, which is a 2. So the slope is a -5/2. Now our third way of finding slope is given an equation. So when we have an equation and we want to find the slope from the equation, we would like for the equation to be in the red form, y equaling mx plus b. We use this form a lot. So now we're going to use this form to find the slope. So in example 1 here, this equation is in the y equaling mx plus b format, in which the m is equal to the 4. So the slope of this line on number 1, the slope is simply 4. Now part 2, this equation does not say y equals, so we need to rearrange the equation until it says y equals. So I need to move the 2x to the other side, leaving a 4y equaling a -2x plus 12. Then I need to divide everything by 4, because I cannot have a 4 attached to the y. It has to just be y. So this results in y equaling a -1/2 x plus 3. So now we are in the y equals mx plus b format, and can now tell you that the slope of this line is a -1/2. So sometimes the equation is given to us and we can just retrieve the slope from the equation immediately, and other times we have to rearrange the equation so it says y equals. Okay, the next way of finding slope is our special cases, meaning our vertical and horizontal lines. Example A, x equaling 3, is a vertical line. When you have a vertical line, your slope is undefined. You do not answer no slope. The answer is slope is undefined. The reason for this is if I pick 2 points off of this line, like the point 3, 1 and the point 3, negative 1, and use the formula for the slope, y2 minus y1 over x2 minus x1, we will see algebraically why the slope is undefined. So the slope would be y2 minus y1 over x2 minus x1, which would be a negative 1 minus 1 over a 3 minus 3, which equals negative 2 over 0, and a 0 in the bottom of the fraction is undefined. Part B is a horizontal line. This is your origin, and this is your line y equaling negative 2. If you have a horizontal line, your slope is 0. Again, your answer is not the words no slope. Your answer is that the slope equals 0. And we can prove this by picking a couple of points, like the point 1, negative 2, and the point 0, negative 2, which I have written over to the right, and applying the formula for slope given 2 points. So this would be y2 minus y1 over x2 minus x1. So this would equal a negative 2 plus 2, which is a 0, over 1, which equals 0, as confirmed when we stated every horizontal line or every constant function. Remember, the horizontal lines are your constant functions, will have a slope of 0. All right, now we're going to change, and we're going to discuss writing the equation of a line. So now we have never been in a situation where we have been required to write the equation until now. And oddly enough, as with so many other things, when we choose to write the equation of a line, we can use this formula in red, y equaling mx plus b, to do that. There is another way of writing it, which we will learn, but for now we're going to limit ourselves to using y equaling mx plus b. So look at example 1. Write the equation of the line with the slope of negative 4 passing through the point 2, negative 3. So I'm going to start with y equaling mx plus b, and I know that my slope is given to me to be negative 4, so I can put the negative 4 in for m. At this point, I almost have the answer, so I'm not going to square it off. I'm going to put dashed line around it. I need to find b. To find b, I return to the given point and use an x value of 2 and a y value of negative 3. So I'm going to replace the y with negative 3 and the x with 2. And when I do this, I'm going to come up with the value for b, which is going to be 5. So now I return to my dash box line and I give the full answer, which y is equal to a negative 4x plus 5. If I graph that line, it will pass through the point 2, negative 3, and it will have the slope of negative 4. Here's another example. Write the equation of the line. So if I'm writing the equation of the line, I'm going to use y equals mx plus b, and they give me the m to be a negative 1/2. They give me slope to be a negative 1/2. So I'm very close to the answer. I just need to find b. So the point they give me is an x value of 4 and a y value of 3. So if I put the 3 in place of the y and the 4 in place of the x, I will be able to solve for b. So this becomes 3 equaling 2 goes into 4 2 times. So a negative 1 times 2 is a negative 2. Then when I add 2 to each side, just oddly enough, I got the value of 5 again, as I did in the last example. And so this answer becomes y equals a negative 1/2 x plus 5. Write the equation of the line with the slope of negative 2/3 passing through the point 6, 0. Again, y equals mx plus b. Now I replace the m with the negative 2/3. And I note that I almost had the answer. I just need to solve for b. So I'm going to put a 6 in for x and a 0 in for y. So 0 will equal a negative 2/3 times 6 plus b. So then 0 equals 3 divides into 6 2 times. I can't even see that too. Hold on, let me try that again. Oh my. 3 divides into 6 2 times. So you have a negative 2 times 2, which is a negative 4. So b is equal to 4. So your equation becomes y equaling a negative 2/3 x plus 4. All right, example 4. Write the equation when the slope is 1/4 and the point is 0, 7. Y equals mx plus b. Y equals 1/4 x plus b. I just need to find the 4. My slope was given to be 1/4. I need to find the value of b. So my x is 0 and my y is 7. So 7 equals 1/4 times 0 plus b. 7 equals 0 plus b, or b is 7. So my answer is y equals 1/4 x plus 7. Now, I want to look at this again, especially number 3 and number 4. If we look at number 4 and we talk about it being in slope-intercept form, we can verify the slope is 1/4 and the y-intercept is 0, 7, which is exactly what they gave me in the question up here. So had I been on top of things, I would have said, hey, that 0, 7 is a y-intercept, so right now I can just say 1/4 x plus 7 is the equation of the line because they gave me the y-intercept. Up on number 3, I could not do that because the 6, 0 is not a y-intercept. It's an x-intercept. So you cannot take that shortcut. You cannot take that shortcut. All right, what if they ask me one more thing? What is the equation of the line when this, and I'm not going to write the whole words. I'm just going to put write the equation. And I'm going to put on here that the slope is 0 and it's passing through the point 7, 12. All right, on this one, when I have y equaling mx plus b, it becomes y equaling 0x plus b. Now that's a little strange, and that's really just a 0, but I'm going to leave it alone for a minute. And I'm going to go ahead and plug in the 7 and the 12 for the x and the y. So 12 equals 0 times 7 plus b, or 12 equals b. So this becomes y equaling 0x plus 12. Well, 0 times anything, including x, equals 0. So this is simply y equaling 12. So recall, if your slope is 0, it's a horizontal line. And a horizontal line is a y equals equation. So it would be logical that the y value would be the same as the y value of the point this line is passing through. We're going to close this recording and maybe continue it a little bit more later.